Hey there, welcome. I wanted to do a very short video on how to measure capacitance. And in your kit, you'll have this bag of inductors and capacitors. There's an inductor right there. The rest of the things are different kinds of capacitors. They are labeled, but because there's a few different kinds of capacitors and they're different sizes and stuff, it can be a little tricky to figure out how to read the label. I don't know if this will quite get in focus. Let's see. Focus. Yeah, oh, come on, you almost did it. It was briefly in focus there for a minute. You can kind of see it says 10N, so this is a 10 nanofarad capacitor. And the way we can measure that is we can turn the multimeter onto the capacitor setting there. I've got my leads attached with the nice clips because they're great for grabbing onto the wires. Most of these capacitors, it doesn't matter, which way you attach them. They work either way. And there we see 9.93 nanofarads. So, the number on top said 10 nanofarads. So very close. So you might be wondering, how does the multimeter make a measurement like that? So what I wanted to do here is I've got my breadboard, and we're going to do a simple measurement with the OpenScope. All right, scooch those things out of the way. We don't need a resistor in there. What I want to do is I want to basically do a capacitance measurement where, there is the capacitor. So let's see, it's plugged in to like some adjacent rows. So that's like, yeah. Can you see the leads? Yeah, I'll bend it so you can see the leads a little bit there. So you can see it's plugged into like rows 20 and 23. I'm going to attach the leads in there. So I'm getting my 10 nanofarad capacitance reading. And now what I want to do is use the OpenScope. So I'm going to use one of these pins. So this is the +1 for the oscilloscope. I want to use the +1, and I'm going to plug it in to basically the positive terminal on the multimeter. So that's row 20, and I'm going to plug the ground. So there's a few different grounds, but this is the kind of the 1- ground. So it's the orange with white stripe cable, and we're just going to measure what the multimeter is doing in order to do this capacitance measurement. So let me jump over to the instrument panel and let me hit run. And there you see what's happening is a series of rising and decaying exponentials, and it's basically using something like the rise time or the decay time to estimate the capacitance. So very similar to what we're doing in this lab. In this lab today, we're not going to be fitting the data, so we're not going to be actually extracting it. We'll actually work on doing some of those deeper analyses next week. I can look in my bag of parts and find a different resistor. Let's see, that one says 10N also. Let me see if this one's labeled in any obvious way. Well, this one, I'm really not sure based on the label. So let me switch over to the camera. So I'm really not sure what value this big gray one has. So I'm going to take out the blue one and replace it. And plug it in. I'll try to hit the same pins that I had before. All right, so it's in there, basically connecting the same way. So this is like a 96 nanofarad capacitor. So it's closer to 100 nanofarads is probably the nominal resistance. And if we go over to the waveform generator, sorry, not the waveform generator, but the oscilloscope, what we see is compared to the last waveform where we had a lot of different periods of this rise and decay, well now because we've got a bigger capacitance, it's a longer rise time or a longer decay time. And so, so that's what we're measuring. I had to change the time scale by 2 clicks. maybe 3 to get something similar, and every 3 clicks is like a power of 10 in terms of time. So we made the capacitance 10 times bigger. It made the rise or decay time 10 times longer, and we have a 10 times bigger capacitance, right? So the technique we're using to estimate capacitance today is basically this, except we're not doing the numerical fitting right now to actually extract an exact value, but we will do that in the near future next week. So hopefully that gives you some sense of what the multimeter is doing. And I think the other thing I hope it shows you is that, like, something like the multimeter doesn't need to be a black box, and you can actually figure out what's going on inside it, and you can use a tool like the OpenScope to basically understand what's happening. Like, what is it doing in order to make this measurement of capacitance? So good luck with the rest of the lab.